A toddler, seeing that his shadow becomes bigger on the wall as he approaches the spotlight, walks closer to it at a pace of 0.5 feet per second. If the spotlight is 10 feet from the wall, how fast is the shadow increasing when the toddler is at the midpoint? The toddler is 4 feet tall. Alright, so we're given this length of the distance from the spotlight to the wall is 10 feet, and toddler is 4 feet. And this is a related rates question. Now, to solve a related rates question, the key is to come up with a simple picture, a simplified picture. And in this simplified picture, you should write in numbers anything that doesn't change. So this 10 feet, that's not going to change, this length being 10. And toddler's height is not going to change. And then you have to introduce variables that are changing and which is also related to this question. So let's think about this pace of 0.5 feet per second. Well, 0.5 feet per second, this is a rate of change of something, so this has to do with a change in quantity. And because that's the pace of toddler walking, he's walking at 0.5, let's think about what changes as he walks towards to this side. Well, as he goes closer to the spotlight, this distance from him to the spotlight is going to shrink, right? On the other hand, this distance from the wall to the toddler will be increasing. Okay? Now, because x plus y is 10, you really don't have to define both. I'll just go with this x. Because if I define this x as to be this length, then I can say dx dt, the rate of change of this distance x with respect to time is negative 0.5, because that's how fast this is shrinking. So as the toddler approaches the spotlight, this distance shrinks, right? So that's why I put a minus there. And then we're looking for how fast is the shadow increasing. So we're looking for this height right here. So let's name that as z or y. Let's use y. Okay, so this will be x, that's y. So we know that this changes, and we're looking for the rate of change of y. And that's good enough, I think. Notice that these are right triangles, and also notice that this hypotenuse length is not really discussed in this problem. It's not really relevant. It's neither given nor it's asked, so probably it's not needed. Okay. And then now, despite this being a right triangle, because you don't need to know the hypotenuse, this is not a Pythagorean theorem problem. I know many of the related rates question is simply just Pythagorean theorem, but here, because we have two right triangles, it's really a ratio between two similar triangles. See, this small right triangle and the big right triangle are similar to each other because they share the same angle here. They're both 90 degrees. So if you took this and blew it up, made it bigger, then it can be this size and it'll match, right? So we're going to say what x is to 4, what this length is to this length, is equal to what 10 is to y in the bigger triangle, right? What 10 is to y. So that's the relationship between x and y, and the question is, what is dy dt when the toddler is at the midpoint? Well, what does it mean when toddler is midpoint? That means this x value will be exactly half of this 10, right? So that's 5. Half of 10 is 5. So that's the question. And you know what? This setup actually captures everything. That's all we need to know. Okay? We have a relationship between x and y here, right? And we're given the rate of change of one thing. And and therefore you just have to figure out dy dt. Okay, so let's just forget about everything else and just write down what we have. Dx dt is negative 0.5. X over 4 is 10 over y. And the question is dy dt when x is 5. Now, to get a relationship between the derivatives, you need to differentiate this. But since you're asking for dy dt, let's just solve this for y. You don't have to. You can still find the solution without solving for y. You can just differentiate as it is. But it turns out that if you solve this for y first and then you differentiate, it becomes easier. Okay. So if you're not convinced, you can also try to solve it without solving for y. Okay, so to solve a ratio, I have to do cross multiplication, right? So you get x times y equals to 4 times 10, which is 40, and divided by x to get y equals to 40 over x. Good. So that's the relationship between x and y. To get the relationship between their derivatives, we differentiate both sides by t. Differentiate both sides, where this prime really means, in this context, it's a derivative with respect to t. And y and x are both functions of t, so although it doesn't look like a chain rule, it's really a chain rule. Y is a function of t, so if you differentiate by t, you get dy dt. Right? Y prime is the same thing as dy dt, it's just a matter of notation. Some people write y prime, some people write dy dt. On the other hand, this side, you have to differentiate this as a function of x. Remember, 1 over x prime is negative 1 over x squared. You can get this using the power rule, but it appears so many times, it's better if you just memorize this. Okay, so please memorize this. Here it's a little different. In this context, I mean the prime is d dx. If you differentiate 1 over x by x, you get negative 1 over x squared. But because in this context we're differentiating by t, and x is a function of t, you really have to differentiate it first as a function of x. Derivative of 1 over x is negative 1 over x squared. I'm just quoting that result up there, right? But in addition, you have to pull the inside function out and you have to differentiate. So you have to pull the x out and you differentiate x by t. So that's what you get, okay? All right. That's actually almost it. What do we have? Dx dt is negative 0.5, right? So we can replace dx dt by negative 0.5. So it's 40 times negative 1 over x squared times negative 0.5. Negative negative is positive. 0.5 is half. Half of 40 is 20. So you end up with 20 times 1 over x squared. Now that almost looks like a solution, except we're not really asking for dy dt, we're asking for dy dt when x is 5, right? So we can finish off this by saying, since dy dt is 20 times 1 over x squared, dy dt when x is 5, you get 20 times 1 over 5 squared. So that's 20 over 25, and if you use a calculator to find that, you get 0.8. Okay? And because our y is measured in feet and time is measured in seconds, the correct unit for this is 0.8 feet per second. Okay, so that is our answer. Okay? Our answer right here. Okay, 0.8 feet per second.